Hello and welcome back. And in this video, we are going to be talking about merging two sorted lists. So this is another very popular interview question, and this one is related to linked list. So basically, for the question, what you've been given is uh, two sorted linked lists. So linked lists are already sorted, and what you need to do is basically merge them in sorted order. Okay. So once again, so basically you have two lists, for example, one and three, and then you have another one, two, three, four. Now you need to merge them and create an output one, one, two, three, three, four. Okay. So the output should be in sorted order as well, right? For added complexity, and this is something you're going to find in most of the interview questions related to linked list, that you're only going to be given the head pointer location, which is not going to matter to you because that's the start of your linked list. So once you know the head, you know what that linked list is. But just so you know, if your interviewer points out that, hey, the input is basically just the node that points to the head, that does not mean anything. It's simply a list being passed as a header pointer, basically. So yeah, so that's about it. So that's just keep that in mind. And now think about this problem itself. So how would you take on basically merge two sorted lists by keeping the order um, basically sorted in the new list? Think about it. Come up with a potential algorithm. So uh, take a pause here and pause the video and take a look, and then we're going to see in a few minutes the solution that we have got for you, and then you can compare your solution with ours. Now, once again, like all algorithm questions and answers, your algorithm can differ. It does not mean that it's actually good or bad. You can actually come up with a totally different algorithm with better runtime. Then we've got. That's great. So just so you know, the problem can have multiple solutions. Okay, so let's take a pause and come back and see the solution. Hello and welcome back, and hope that went well. So let's take a look at what we have got. So before we actually dive into the solution, let's take a look at the flow, how it's going to work. So basically, we're going to have two lists. For example, we had one and three, and then we have one, two, three, four, the other list, and we have head pointers pointing, and that's actually the current loop. So what we're gonna do is we're gonna loop through these elements and compare them with each other. Okay. And while comparing, we also gonna have a third item, a third list basically that's gonna point to -1 as head. Okay, so that's gonna be our return, our result list. Okay, so what we're gonna do is we're gonna compare in the loop if heads current pointers for both lists are pointing to the element, are they list one is less than list two. Okay, so we compare, we say, well, they're equal, so it doesn't matter. Take one and put it into the results list and move the pointer. Now compare them. So now two and one are compared. One is smaller. You insert one and move that pointer. Okay, so you're moving pointer tandem style. That means you're moving one pointer at a time in one loop cycle. So in second loop cycle, you're gonna move the other pointer. So that's how you're gonna actually compare values to each other and basically insert items into the list. So similarly, now you compare two and three, and you move two and then move the pointer, and now it's pointing three and three, so we can now move the other three. It doesn't matter which one. So then the loop is gonna go and point the other three, and now first list has ended here, right? So this is where we can actually consider we're gonna we're gonna go out of the loop, right? And once we go out of the loop, we wanna actually add. You can see the four is remaining here, right? So what we can do is we can check, is list 1 nil? If it is nil, check list 2 as well. Is it nil? If it's not nil, add all the elements that are there in list 2 into the result list. So that's what we're going to do. We're going to move our pointer and basically move 4 into the list. And then we get our final result, which is a sorted linked list combining those two sorted lists. Now, you must be thinking that -1, what we're going to do with that. So we are simply going to override the head to point head dot next, and then it'll start pointing to 1. Okay, so you're going to see in the code and understand. But basically, that's the operation that you're going to take to solve this problem. Okay, so let's go ahead and take a look at this in code as well. So I've got same stuff here. So we have got linked list, node, and main. We're not going to use linked list. We're going to work with main just to, follow the same level of same way, like, for example, our interview has asked us that we are only given the head, so that's what we're going to assume. Okay, so we're going to create our function first. So let's go ahead and create our function, merge to list. And we're only going to take pointer, okay? So we can only take pointer. So we can take node and going to take node again. And this is also going to return a node. All right. Okay. Now, this is Swift only thing. We are going to actually create a local variable. So we're going to say list1, or let's say root1, right? And it's going to be list1 L1, and root 2 is going to be L2. Yeah, it's going to get updated, so let's not call root. Let's not get confused with it. List 2. Okay. Now, we also want to create our result. So we're going to create our node with data as -1. And we're going to create our head, and head will point to result. Okay. Now our comparison starts. So we're going to say while list1 is not equal to nil, right? So first thing we're going to check. And, okay, list2 is not equal to nil. So any of these go nil, we exit out of the loop. And then we compare. We say if list1, right, dot data is less than list2 dot data. If it is, then we should take a result, and we should say result dot next is equal to list1. Okay, and this is where we can update our list1 to point to list1 dot next. So we're going to move our pointer to the next element now. Okay, now else. So this is where it's going to be. So in the first iteration, only one of these are going to compare. So only one of the pointer is going to move. So in the next one, we're going to say result. Let's make result optional as well. So for consistency, result dot next is equal to list2. Okay, because if let's say list2 is so list1 data is smaller than list2, then go here. But if list2 is smaller, then go here. Okay, so we're gonna say result dot next, and list2 is equal to list2 dot next. Okay, right? So we increment these, and we continue forward. And while we are actually doing this, we also want to continue moving our result to result.next. So we point to the right element. Okay, there we go. All right. So now we are continuing, continue to move forward, and one of the lists becomes nil. Okay. When one of the lists becomes nil, that's when we need to check if that means that our loop is going to end, right? So when our loop ends, then we need to check if there is any remaining elements. So we're going to say list1 is not equal to nil, then take that and put it as result.next. Okay, whatever remaining it's pointing to. Now remember that remember that like list where pointer is constantly being updated. So list one or list two will point to the remaining item. It's not going to point to the head anymore. Okay, so that's why that's the advantage that we're going to take. Now our list is created. Okay, and this is where we need to make that decision of like removing the head. So let's consider our head. Now head was pointing at -1, so we're gonna say head dot next. Okay, that way our head is pointing to the next element, which is the actual sorted list, start of the actual sorted list, and then we're gonna return the head. Okay. All right, so this is our merge list. Now let's go ahead and test this out with our data. So we're gonna create list 1, and we're gonna say node data 1. Okay, was list. Oh, sorry. List 1 dot next is node data 3. Okay, so that's what we had, 1 and 3. Yeah, so that's list 1, and then we create our list 2, 1, list 2 dot next is equal to node data, and we have here I think 2, 3, 4, right? So 2, we copy that dot next 3 dot next, and this is 4. Okay, now we're gonna combine these two. So we're gonna say gonna take the output of this into a variable. So we're gonna call this head or result, maybe merge to list, and we're gonna say list 1 and list 2. Okay. Now we're gonna get the result. So we're gonna create a variable current that's gonna point to result, and we're gonna say while current is not equal to nil, right? We're gonna say print current dot data and current is equal to current dot next. So this is gonna loop over the newly created list, and we're gonna print that out. So let's go ahead and run this if we made any mistake. Okay, so everything looks good. So we inserted one and 2, 1 and 3, and what we got the result as 1, 1, 3, 3, 3, 4. So that is sorted, and it has considered all the elements into the list. Okay, so this is how you actually merge two linked lists by, once again, tandem iterate and increment their pointers, so one after the other in each iteration, and then you actually compare their values and put it into the new result list. Time complexity for this one is O of n, because we are only inside the loop once, and we are actually only iterating over once, so n times. So that's what we have. Okay, so that was the solution we've got for you guys for merging two linked lists, and hope you guys enjoyed this video, and thanks again for watching. I'll see you guys in next video. Thank you.